Welcome to this session. In this session, we are going to discuss about how the operating system is helping in process management, memory management, and storage management. So, first of all, what is process? So, process is nothing but the execution of the program. So, we know the very well the program is passive entity and then process is the active entity. It's like as the unit of work within the system. The process needs some resources to complete its task. So if any one process is coming, so obviously memory and in storages, so all these things is considering as the resources. Any one particular task is assigned for the process, it needs some resources to complete its task. So like CPU, memory, IO, and then files, some initializing the data. These are the things. Once the process is complete its task, so it needs to terminate its work. So at that time, the resource is going to be reback to the OS. Each and every process, if the process contains a single thread, it's a single execution, means it's called as a thread is called a single execution. If the process contains the single thread process, means it has only one program counter. So what is the role of the program counter? Means, so we know very well it's a process is a program execution. So the execution, the instructions are going to be set of the things. So the program contains a set of instruction. So which instruction is going to execute next? So that information available under the program counter. So if the process in a single thread process, means it has only one program counter. So to execute, so where we need to start and what is the instruction for the next things. If the process in multi-thread, means so each and every thread has one program counter. So one program counter per thread, like that it was initialized. So typically the system has many processes for the some users, and some operating systems are running in a concurrent manner. So that is a one or more CPUs will be there. So these are all the things are the narrative information of the process management. Next thing, the process management under that, so yes, what are all the responsibilities it's taking care. The first thing is creation and deletion for the both the user and then system process. If your process is created, means the creation of the process, after the finishing the deletion or intermediately if anything is there, means we are just suspending the process, passing the process. After completing the interruptions, again we are going to be resuming the process, and we are just providing some process synchronization mechanisms, and it is helping us for the process communication, one process and then another process, how it is going to be communicated. And during the execution, if anything has happened for the deadlock, so deadlock is nothing is going to be happen, all the processes in a dead stage, that is the stage for the deadlock. So in that time, so how it is going to be handling all these things is the responsible by the operating system. Next thing is the memory management. So to execute the program, so complete program or pathing, whatever it is, so the instruction must be in a memory. So what is in a memory means, so all the part of the data it's needed by the program must be in a memory. So the program it's having some data, that data it's going to be stored under the memory. So the memory management is determining first things what is in the memory. So what are all the data we have to keep in the memory, and when. So all the times all the data can't be available ready to use, right? So when the data is going to be available in the memory, and what kind of the data are going to be available in the main memory. So because of that, we are just optimizing the CPU utilization as well as the computing responses to the users. And what are all the main memory management activities taken care by the operating system? Means the first things, it's keeping track of which part of the memory or currently being used and then by whom. So what are all the memories are going to be used currently and who is the user of that. And second thing, we are just deciding the process, the data, whether it's in a move into the memory or what kind of the data we are going to be move out from the memory. So I already told, right, all the data are not ready to use in the memory always. So sometimes we are just kept inside the main memory. If not in a use for the huge time, so we are just moving out from the main memory. So what kind of the data we are going to be moving and move out, all these things is decided by the OS under the memory management. And next thing is allocation and deallocation of the memory spaces for the each and every process. Next one is the storage management. If you are just checking the storage management, so OSS provides a uniform and logical view of the information storage that is called as a files. So each medium is controlled by some devices like a disk drive, tape drives, or whatever it is. It's varying the properties, it's including the accessing speed, capacity, data transfer, and accessing methods and everything. Later we will just discuss what are all the storages devices are available, how it is categorized based on their speed and then storage capacity. If you are just taking the file management, so usually the files are organized into the directories. The control access controls is most of the system to determine by who can access it and what kind of the data are going to be accessed. If the number of the user is there, now all the users can't able to giving the access for all the files. So we are just giving the restrictions for who can access and up to what limit they can do the modification on the particular data. So OS's activities, what are all the activities is there under the file management means the first thing is creation and deletion of the files and then directories, and manipulations, what kind of the manipulation we can do it, and mapping the file into the secondary storages and backupping the files. So these are the things are main activities of the file system management. So when we are comes to the mass storage management thing, in the sense, the first thing, usually the disk will be help us to storing the data. This is not fit in the main memory. So all the times we can't able to store the data under the main memory itself. In that time we will just doing the help for the disk. So for long term period process, so we are just storing the data under the disk. So proper management of the central important things. So the entire the speed of the computer is mainly rely on the disk and its algorithm only. Okay, so what are all the activities means the free space management, storage allocation, and disk scheduling. So based on these things, the entire the computer system, the speed is going to be calculated. So the next one is these are all the storage devices hierarchy. So by the diagram itself we know very well the capacity wise it was listed. The registers are very small capacity, and then cache and main memory, solid state, hard disk, optical disk, and then magnetic tapes. So when the storage capacity is going increased, the speed is going to be decreased. So when we are just storing some information in a registers, it's immediate action. So it's a only one instruction it's going to be stored under the register. That's a very immediate actions. So similarly the cache memory, so the fastest one, and then main memory, so the capacity is going to be increased, the speed is going to be decreased. The speed is going to be increased, the capacity is going to be decreased. That is a vice versa. By seeing this chart, you can easily understand. So how much the sizes are there. So the register storage sizes are less than 1 KB, but the magnetic disk, if you are just saying so nearly the 10 TB, we can able to store it. So accessing speed for the registers 0.5 milliseconds, even it's a point nanoseconds, not a millisecond, sorry, nanoseconds. So like that it is mentioned. So this is a chart is given for the performance of the various level of the storage systems. Thank you.